Hello viewers, in today's session we are going to discuss an important concept from tangents and normals, and here we are going to discuss the concept of angle of intersection of two curves, right? And moreover we'll also see the condition for the orthogonality of two curves, right? So let us start, and let us first see what is the meaning of angle of intersection of two curves. Now consider the equations of two curves. Suppose the first curve is given by, say, y is equal to f of x, and the second curve is given by y is equal to say g of x. So this is curve c1 and this is curve c2. So now let us draw a rough diagram of these two curves, and suppose here we have the coordinate axis. This is x-axis and this is y-axis, right? And let us draw the curve c1 like this, and let us draw the curve c2 say like this. So this is y is equal to f of x. So this is the curve c1, and this is the curve y is equal to g of x, and this is our curve c2. Now here this is the point of intersection of the two curves c1 and c2, right? So at the point of intersection of these two curves, let us draw tangents to these two curves. So the tangent to this curve c1 it may be drawn like this, and let us draw the tangent to this curve c2 like this. Suppose this is the tangent to the curve c2. So now let us denote the tangent to the curve c1 by L1 and the tangent to the curve c2 by L2. And let us take the slope of this tangent, that is the tangent to the curve c1, that is the slope of the line L1 equal to say M1, right? And let us take the slope of the line L2, which is the tangent to the curve C2, as M2, right? Now suppose the angle between these two tangents is say theta, right? So theta is the angle of intersection of these two curves at the point of intersection of these two curves. So we know that the angle between the two lines L1 and L2 is given by this result, that is tangent theta is given by m1 minus m2 divided by 1 plus m1 times m2, and we take the absolute value, right? So here the angle between these two tangents is given by theta, and tangent of theta is given by mod of m1 minus m2 divided by 1 plus m1 times m2. So now let us consider the condition for orthogonality of two curves. Suppose we have two curves C1 and C2 whose equations are y is equal to f of x and y is equal to g of x. Now if these two curves C1 and C2 intersect at right angles, then they are said to intersect orthogonally. And the condition for orthogonality of two curves C1 and C2 is that the angle between the tangents to the two curves at the point of intersection of curves should be equal to 90 degree, right? So when theta is given by pi by 2 or 90 degrees, then the two curves are said to intersect orthogonally, right? So the two curves are at right angles when the angle between the two tangents to the two curves make an angle of 90 degree, right? So when theta is equal to pi by 2, then the two curves are said to intersect orthogonally, and the condition for two lines to be perpendicular is that the product of their slopes must be equal to -1, right? So this is the condition for orthogonality of two curves, C1 and C2. So now let us understand this concept with the help of this example. And here we have to find the angle of intersection of these two curves, right? So here we are given two curves C1 and C2. So the equation of the first curve is given by y is equal to f of x, that is 4 minus x square. And the equation of the second curve is given as y is equal to g of x, that is x square. And here we have to find out the angle of intersection of these two curves, right? So before finding out the angle of intersection of these two curves, let us first find the point of intersection of these two curves. So to get the point of intersection of these two curves, we have to solve these two equations, right? So here we have y is equal to 4 minus x square, and this is y is equal to x square. So we can equate both these expressions. So we have 4 minus x square is equal to x square, that is x square plus x square, taking minus x square to the right hand side. We have 2x square is equal to 4. So we have x square is equal to 4 over 2, that is 2. So x is plus minus square root of 2, right? So x is equal to plus minus square root of 2. So let us substitute the value of x in this equation to get the value of y. So we have y is equal to 4 minus x square. So x is square root of 2 square. So we have y is equal to 4 minus 2, that is equal to 2. So the point of intersection of these two curves is given by plus minus square root of 2 comma 2, right? So here we see that we have 2 points of intersection of these two curves C1 and C2. So the first one is plus square root of 2 comma 2, and the second one is minus root 2 comma 2, right? Okay, so now let us find out the slope of the tangent to the first curve, that is C1, and the slope is given by m1, and m1 is given by the derivative, that is dy over dx. So we'll take the first function, that is y is equal to 4 minus x square, and differentiating both sides we have dy dx of 4 minus x square, that is equal to minus 2x, right? And the slope of the tangent to the curve C2 is given by m2. So m2 is given by again by the derivative, that is dy over dx. So differentiating this function, we have dy dx of x square, that is simply 2x. So now let us find out the value of the slopes m1 and m2 at these points, right? So let us first take this point, that is plus root 2 comma 2. So the value of m1 is given by minus 2x. So taking x is equal to square root of 2. So we have 2 times root 2, and the value of m2 is given by 2x. So this is 2 times root 2, because the value of x is plus square root of 2, right? Okay, so now let us substitute these values of m1 and m2 in this formula. So the angle between the two curves is given by tan theta is mod of m1 minus m2, so we have minus root 2, and then we have minus 2 root 2 divided by 1 plus m1 multiplied with m2. So here we have minus 2 root 2 and here we have 2 root 2. And solving this, we have here in the numerator minus 4 root 2, and here we have 1, and this is 2 times 2 4, 4 times 2 is 8, so we have minus 8. So we can now write a mod of minus root 2 minus 4 root 2 divided by minus 7, and cancelling this, we have 4 root 2 over 7, that is simply a 4 root 2 over 7, right? So in this case, the angle between the two curves is given by the angle between the two tangents. So we have tan theta is equal to 4 root 2 over 7, that is theta is equal to tan inverse 4 root 2 over 7, right? Now let us take the second point. So when we take the second point, we have minus root 2 comma 2. In this case, the value of x is minus root 2. So the slope m1 is now given by minus 2x. So this is minus 2 times minus root 2. That is simply 2 root 2. So minus times minus is positive, and m2 is given by 2x, so we have 2 times minus root 2, that is minus 2 root 2. So now the angle between the two tangents or the two curves is given by tan theta, and we have m1 minus m2, so m1 is 2 root 2 minus minus 2 root 2, and then we have 1 plus 2 root 2 times minus 2 root 2. So substituting the values of m1 and m2 in this result. So now we can simplify. So this is 2 root 2 plus 2 root 2 divided by 1 minus 8, because 2 root 2 times 2 root 2 is 8. So we have mod of 4 root 2, and here we have minus 7, and when we take the absolute value, then this becomes positive, so we have 4 root 2 over 7. So in this case, we have tan theta is equal to 4 root 2 over 7, that is theta is equal to tan inverse 4 root 2 over 7. So this is how we can easily understand how to find the angle of intersection of the two curves. So now let us consider the second problem, and here we have to find the condition for the curves y square is equal to 4x and xy is equal to k, where k is some real number to intersect orthogonally. So here we are given the equations of two curves. C1 is y square is equal to 4x, and C2 is given by the product of x and y is equal to k. K is some real number. So here these two curves are to intersect orthogonally. It means that the tangent should be at right angles. That is the angle between the two tangents to the two curves at the point of intersection should be equal to 90 degrees. So the condition for orthogonality of two curves at the point of intersection is given by m1 times m2 is equal to minus 1, right? So we'll use this condition, m1 times m2 is equal to minus 1. So m1 is given by the derivative, that is dy over dx, and dy over dx should be calculated from by differentiating the equation of the curve c1, right? So here if we differentiate both sides, then we get 2y dy over dx, and here we have 4 times 1, because the derivative of x is 1, and we know that the derivative of y square with respect to x is 2y dy over dx. So now from here we have dy over dx is equal to 4 over 2y, that is equal to 2 over y, right? So m1 is now given by 2 over y. Now let us calculate m2, that is given by again dy over dx, and in this case dy over dx is to be calculated from this equation, that is the equation of the curve c2. So differentiating both sides, we have a dy dx of xy is equal to a d by dx of k. Now this is a constant, so the derivative is 0, and here applying the product rule, first function derivative of second, then second function and derivative of first function, and this is equal to 0. So from here we can now write x dy over dx plus y times 1 is equal to 0. So we can now write x dy over dx is equal to minus y, taking this y to the right hand side, and dy over dx is equal to minus y over x, right? So now the value of m2, which is dy over dx, so m2 is now given by minus y over x, and m1 is given by 2 over y. So now let us find out the point of intersection, that is P of these two curves C1 and C2. So let the coordinate of the point of intersection of the curves C1 and C2 is given by alpha comma beta, right? So now what we will do, since this point lies on both the curves, so this point should satisfy both these equations, right? So here first we'll substitute this coordinate in the equation of c1. So we have beta square, for x we have alpha, for y we have beta, so we have 4 alpha, and then we'll substitute alpha comma beta in the equation of the curve c2. So we have alpha times beta is equal to k, right? Okay, so now if we solve these two equations simultaneously, then we can find out the values of alpha and beta in terms of k, right? So now the slopes are given by these two expressions. So let us substitute the values of x as alpha and y as beta in m1 and m2 to get the slopes at this point, which is the point of intersection of these two curves. So now m1 is given by 2 over beta, because y is beta, and m2 is given by minus beta over alpha, right? And since these two curves intersect orthogonally, so the product of the slopes must be equal to minus 1. So we have 2 over beta times minus beta over alpha is equal to minus 1, substituting the values of m1 and m2 in this condition, right? So beta and beta get cancelled, and we have from here minus 2 over alpha is equal to minus 1. So minus 2 is equal to minus alpha. So multiplying alpha with minus 1, minus and minus get cancelled, so alpha is equal to 2, right? And let us substitute the value of alpha in this equation to get the value of beta. So we have beta square is 4 times 2, that is 8. So beta is equal to square root of 8, that is 2 times square root of 2, right? So now let us substitute the value of alpha and beta in this equation. So we have now a 2 times beta is 2 times root 2, and here we have k. So k is equal to 2 times 2 is 4, so 4 root 2. So this is the condition, that is k should be equal to 4 times root 2 when the two curves y square is equal to 4x and xy is equal to k intersect orthogonally.